All right, welcome back, analysts. That's a real name for somebody who does calculus. They're not calcsters. That's just a fun name. Okay, checking stuff out. Number 11, we're just going to check a couple little things. If we need to do the whole problem, we can. But we are checking 11, 17, and then AP 1 and 4 here. And let's go to the right screen. Here we are. And we're just going to check a couple things. First thing I want to check, and I want you to check, and don't count it wrong if not, but if you've done them right, we should have a few things. Do you have a sphere drawn? I would always encourage you to. If you don't, I'm not going to take points, but it will help. Maybe not so much in this problem. What is your known information? dsdt is 0.1 or 1/10 centimeter squared per hour. Okay, what are you trying to find? Not the radius, the changing radius, dr dt. And just to check, it's tiny. Do you guys have it in scientific notation? And should we review scientific notation stuff, chemistry people? Do we need to review it? Okay. Is your answer in scientific notation or a terrible decimal? Okay. The book's answer is a terrible decimal, but I wouldn't have this. I would have this in scientific notation. So 0.000625, that's 625 millionths. Gross. Okay. How do we write this number in, like, they don't do what we should? Negative means what? It's shrinking. So in your statement were your words. The sphere, how do you word it? Did you practice this sentence as your answer? Okay. I assume that means it's not a good answer. Looking at this, do me a favor. The context is just we have a sphere that's shrinking. That's it. I want you to give me the context here. You don't have to write it down. You can, and it's good practice. But how do we word this? The fact that it's this answer. What's that? Like, yeah, how do we write this? The sentence, not the number. Like, I know how to write the number. It's right here. What's the sentence say? When the radius, so I almost love it. If you're, so you know it's, and I like everything except for one word that you said. Otherwise, it was perfect. This negative tells me the radius is doing what? So if you're already saying it's shrinking, don't include the negative. The radius shrinks at, and we'll just use the absolute value. We don't need the negative. The negative is in the answer numerically, absolutely. But the second you say it's shrinking, that implies like the negative is there. Because if we shrink at a negative, that would turn into a plus, is what would happen if we think about it the same way. We just say shrinking at, and I'm going to change this. Where should the decimal go if it's scientific notation? Here it is. Between which two numbers? This should be 6.25 times 10 to the, and let's see. I need to go from here. How many to the left would I move? 1, 2, 3, 4. So it's negative to begin with, times 10 to the negative 4. This just tells me move the decimal 4 left. Always a number between 1 and 10 centimeters per hour. I don't really mind whether you have it numerically as this ugly decimal or this, but it's good. Like, this is a situation where it makes way more sense to use this. Cool. All right. On 17. Cool. Hey, look, it's another spherical balloon. And we're filling it with, nope. It is filled with gas. And there's a leak that causes the gas to escape at that. What is the radius surface area of the balloon shrinking when the radius is 4? So, same thing. You probably have a sphere drawn with a sweet... do you have a circle or sphere? Just out of curiosity. Everybody add an equator? Cool. All right. So, with this, what's your known? dv dt equals what? Negative 1.5. And again, it's that language, right? The fact that gas is escaping means I'm losing volume. Negative. Okay, you were trying to find ds dt when r is 4. This is a much more involved problem, very similar to the one that we did in class, right? Where we get the dr dt, you have to solve for it. When you do this, and it's all said and done, negative 0.75 meters squared per minute is what I'm looking for. And I'll read it again, or say it again. I'll show it. The surface area of the balloon is decreasing by 0.75 square meters per minute when the radius is, lost my spot, 4 meters. I love that. I like that. Negative 3/4? Or did you keep it an uglier fraction?
Negative 3/4.
Did that come from an uglier number?
Yeah.
Okay, what was your uglier number? Or the uglier fraction? So regardless, I'm just going to pretend like I know what it is. I don't know what it is. If we get an answer like this, let's say it's 2736. This is 3/4. Like, at this point, it sounds super strange, but here's the deal. This answer's fine. If you simplify, the answer's also fine. But if you make a mistake from here to the end when you're simplifying, you're going to get points off. Like, you don't have to simplify in here. Same thing, we don't have to keep radicals in the numerator or anything. You're welcome to, and I'll do it a lot of the time because it makes stuff easier to think about. But on the AP test especially, there's no points awarded or taken away if you don't simplify. Let's just avoid the mistakes in that situation. Okay, I'm cool with negative 3/4 or negative 0.75 or whatever. I don't know what the fraction actually was, but that's a fraction. Okay, those two felt okay, felt terrible. If anybody wants to work through one of these, we're going to do some different ones today. I think I'm going to hold off for the worksheets until Monday when the girls are back also, just so that everybody can get one. But we have more problems we can do today, all the same. Sweet. All right, how are the AP problems? Number 1, hey, a spherical balloon. Look at this. We do a lot of sphere stuff in here. We're inflating it, so I see right away ds dt is positive 50 cubic meters per minute. That's a lot of air. All right, find the rate at which the radius is increasing. It's that same sort of problem, and we all get 1/8 pi. Okay, it is Charlie. 1/8 pi. Now, did you guys use your notes and what we already did to find dr dt to simplify these problems? I would have, and if you didn't, you probably did it a couple times and it took a lot of work, because if we solve surface area for radius and dr dt specifically, we get the same answer every time, right? Because it's always 4 pi r squared. We're always going to do the same thing. Okay, and then number 4, right? Which one of these? The radius of a sphere is increasing. So what are you given on number 4? What equals, go ahead, sorry. dr dt is 2 centimeters per second. When r is 12, what is the change in surface area of the sphere? So look, and here's what I was alluding to. These are like the real AP problems. You're not expected to remember the surface area of a sphere. Like, I don't remember it. I had no idea what it was until we looked at the reference sheet yesterday. Not a clue. But I think it's 192 pi cubic centimeters per second. Delta. Cool. Related rates are super scary problems. Are they super hard? They're pretty hard problems. Have you done stuff that's harder than these? I legitimately don't know. I don't think you've done word problems that are as hard as these, but I also haven't taught all your math classes. It's hard for me to think of something harder that you've done. Really ugly chain rules, maybe. I don't know. Cool. Oh, Mickey thinks she knows what the wheel's gonna do.
Mickey, shut up. It said you were gonna collect them.
Okay, I believe you. I will collect them. Did I really?
Yeah.
Okay, I believe you. I don't remember it. Why did you not want to collect it? Did you do it, Bea?
Yeah.
Oh.
I just want to look at it.
Okay, I will give it right back. I'll give it back today because I'm going to give you guys problems, and when it takes you guys 5 or 10 minutes to do a problem, I'll just grade them and give them right back. Cool. Will you guys all pass those over to Bea, and then Bea is going to set them on the stool in front of her. Cool. So, because the girls that are traveling don't have the worksheets, and I don't know if they're going to be able to find a place to print the PDFs, we're going to do a couple more types of problems today. And then I had this other idea that I'm open to.